Tesla's November 6th pre-order just got controversial. The $15,990 Model 2, limited to 10,000 units, is reportedly getting Starship's transparent aluminum glass, the same material designed to stop .50 caliber bullets and survive meteoroid impacts. But here's the problem insiders are whispering about. This Elon glass costs 5 times more than regular windshields. Internal estimates suggest it could push the real price toward $30,000 or $40,000. So which Model 2 are you actually getting on November 6th? The $15,990 version or the Starship grade armor? Let's talk about what Tesla isn't telling you about November 6th, because the numbers simply don't add up when you dig deeper. Internal sources confirm Tesla's setting specific requirements for Model 2 pre-orders: region restrictions, income verification, and undisclosed basic conditions. Once 10,000 reservations hit, the portal closes without warning. This isn't how normal product launches work. When Ford opened Mustang Mach-E reservations, anyone with $500 could get in line. Tesla's conducting a controlled market experiment, testing who actually qualifies for a $15,990 EV and whether these buyers will accept the compromises necessary to hit that price. What makes this suspicious is timing. Tesla's Q2 2025 report confirmed Model 2 production started in June at Giga Texas, giving them nearly 6 months to build inventory. So why artificially limit the first batch to just 10,000 when Elon's promised 500,000 annual production from Texas alone? The answer likely lies in the glass controversy quietly brewing inside the company. Transparent aluminum, officially called Elon or aluminum oxynitride, isn't science fiction. It's the same ceramic alloy protecting Starship's windows during atmospheric re-entry at temperatures exceeding 3,000 degrees. NASA's proven it stops micrometeoroid impacts traveling at 45,000 miles per hour without chipping. The specs are remarkable. Just 0.16 inches of Elon stops .50 caliber bullets, requiring 3.7 inches of traditional bulletproof glass to achieve the same. It maintains structural integrity for 70 years. These aren't marketing claims, but verified aerospace engineering data. Here's where reality crashes into hype. Commercial Elon costs $1,440 to $2,160 per square foot versus $2 to $3 for conventional glass. A compact crossover uses approximately 40 square feet of glazing. Even if Tesla negotiated bulk pricing to $500 per square foot, you're looking at $20,000 just in glass costs for a $15,990 vehicle. The economics literally cannot work unless Tesla's using Elon selectively or charging substantial premiums. Images from Giga Texas show prototypes with covered windows. Engineers confirm they're testing entirely new glass material, but nobody's specifying which trim levels receive it. The logical scenario: a base model at $15,990 with conventional glass, while an Elon-equipped version commands $30,000 to $35,000. That's not conspiracy, but basic manufacturing economics. What's actually revolutionary, though few notice, is Tesla's structural redesign using high-strength steel instead of aluminum. This sounds like cost-cutting until you understand the engineering. The steel is the same advanced alloy from Cybertruck's exoskeleton. It costs 60% less than aerospace aluminum, increases torsional rigidity by 20%, and in crash tests, Model 2's structure withstands forces 1.5 times higher than U.S. safety standards. Steel adds 5% weight, but Tesla's offsetting this through Unboxed manufacturing. Traditional assembly is inefficient. Workers crowd around a 16-foot vehicle, creating bottlenecks. Tesla's Unboxed approach treats the vehicle as separate modules. Outer panels, doors, and front end are painted independently, then converge in final assembly. The structural battery pack arrives with seats installed and lifts into the chassis from below. This cuts manufacturing costs by 50% and floor space by 40%, enabling credible $10,000 production costs while maintaining margins at $15,990 retail. The challenge is that Unboxed manufacturing only works with the new NV9X platform and requires massive gigapress castings. Tesla's only fully installed this at Giga Texas, and the process is still being refined. That 10,000 unit November batch likely represents maximum output while perfecting tolerances. If quality issues emerge, those pre-orders could transform from marketing triumph to customer service nightmare. Now the battery situation, where marketing fantasy collides with engineering reality. Promotional materials claim aluminum-ion batteries could deliver 700 watt-hours per kilogram, enabling 1,000-mile range and 10-minute charging. These numbers would obliterate every EV in production. One problem: aluminum-ion batteries don't exist in any production vehicle worldwide. They're lab prototypes facing massive scaling challenges. Current lithium-ion cells peak around 200 watt-hours per kilogram. Tesla's 4680 cells achieve 275 watt-hours per kilogram. Even if aluminum-ion reached 500 watt-hours per kilogram in production, you'd get 600-mile range. That's revolutionary, but battery researchers suggest we're 5 to 7 years away, not November 2025. Tesla's actually installing lithium iron phosphate cells, rated 90 to 160 watt-hours per kilogram. These are proven, cheaper, safer, and manufactured at scale. A 53 kilowatt-hour LFP pack delivers the stated 250-mile range for base Model 2. The long-range version gets 55 kilowatt-hours, pushing 310 miles. These are realistic numbers at $15,990 and $25,000 price points. The aluminum-ion promotion serves different strategy. BYD's preparing to export their $10,000 Seagull, delivering 220 miles on LFP. By announcing breakthrough batteries coming soon, Tesla freezes the market, convincing buyers to wait instead of purchasing Chinese competitors today. It's strategic positioning, but potentially misleading thousands expecting 700-mile range. This raises whether $15,990 is even sustainable. Tesla sources 30% of components from Mexico, where new tariffs could add $2,000 to $3,000 per vehicle. U.S. battery production costs $140 to $165 million per gigawatt hour versus $110 million in China. Material inflation and supply pressures are hammering margins that dropped to 16.3% in early 2025. Tesla's countering with three strategies. The KTL Michigan battery plant, launching in 2026, localizes supply chains. Giga Mexico will target 10,000 weekly units, leveraging scale. Most importantly, Tesla is banking on software subscriptions, particularly full self-driving at $1,200 to $2,400 annually. If 30% of Model 2 owners subscribe, that generates $360 to $720 million recurring revenue on 1 million vehicles. My analysis suggests Tesla can sustain $15,990 for 12 to 18 months post-launch through mid-2027. After that, expect adjustments pushing base price toward $18,000 to $20,000 with long range at $28,000 to $30,000. Starship Glass's premium package likely adds $5,000 to $8,000, putting fully loaded Model 2 near $24,000 to $26,000. Despite these pressures, Model 2 has one advantage Chinese manufacturers cannot replicate: the integrated Tesla ecosystem. BYD's Seagull offers impressive value at $10,000 with 220-mile range, but lacks over-the-air updates, has no supercharger network access, offers limited autonomous driving, and carries minimal brand prestige in Western markets. Model 2 includes full self-driving hardware standard, connects to 50,000-plus superchargers globally, and benefits from software-first philosophy where vehicles genuinely improve over time. Even if BYD undercuts on sticker price, they can't compete on total ownership cost factoring, charging convenience, software capabilities, and resale value. The real question is whether Americans accept a stripped-down Tesla. Base Model 2 reportedly eliminates rear displays, ambient lighting, ventilated seats, power folding mirrors, and premium materials. The touchscreen shrinks from 15.4 to 12 inches. Some specs mention single-axis manual seat adjustment and fiberglass roofs. This isn't premium Tesla experience, but an affordable EV wearing a Tesla badge. So what does November 6th represent? A $15,990 base model with LFP batteries, 250-mile range, conventional glass, and reduced features. Or a $25,000 to $30,000 long-range version with better materials. 250-mile range, conventional glass, and reduced features, 310-mile capability, and possibly Starship glass as expensive upgrade. The 10,000-unit limit tests production workflows and gauges market demand. If units sell out in hours, expect pricing to drift upward. If reservations linger, Tesla might introduce incentives. So here's the truth about November 6th. Tesla's offering two completely different vehicles under one name. The $15,990 Model 2 is real, but it comes with conventional glass, LFP batteries, and 250-mile range. The Starship glass version with ALON technology, that's a premium model likely costing $25,000 to $35,000. Tesla's betting most buyers won't read the fine print until after they reserve. This isn't just about one affordable EV. If Tesla pulls this off, they prove electric vehicles can undercut gas cars on price while maintaining quality. If they stumble, it hands the American market to Chinese automakers like BYD, who are ready to flood dealerships with $10,000 EVs. Here's what I need to know from you. Would you buy the $15,990 base model now, or wait and pay extra for Starship glass later? Drop your answer in the comments because your strategy could determine which version Tesla prioritizes. If this breakdown helped you understand what's really happening with Model 2, hit that like button. Subscribe to Tesla Zone so you don't miss our coverage when the November 6th pre-orders go live. We'll be analyzing exactly what Tesla delivers versus what they promised. And turn on notifications because the next 72 hours will be critical. This is Tesla Zone. We don't just report Tesla news, we decode what it actually means for you. The Model 2 revolution starts November 6th, and we'll be here separating reality from hype every step of the way. $9,990 for a Tesla motorhome. Elon just confirmed it at the shareholder meeting. A vehicle that's also a fully functional home for under 10 grand. Tesla's cheapest car costs $40,000, yet they've cracked the code to deliver this at a fraction of that. How? Musk revealed it's built on 70% of the Semi's platform, the same truck hauling freight for major companies right now. They transformed a commercial workhorse into a home on wheels. But what mind-blowing features justify this price? And can it really ship in 2026? Let's address the question everyone's asking first. How does Tesla deliver a livable motorhome for under $10,000 when building vehicles from scratch has always been their biggest challenge? The answer reveals something most people completely missed about this announcement. Tesla didn't start from zero. They transformed an existing platform that's already proven itself hauling freight across America. At the shareholder meeting, Musk confirmed the motorhome uses 70% of the Semi's architecture, which means Tesla bypassed years of research and development, billions in new tooling costs, and the production nightmares that have delayed every major vehicle launch in their history. The Semi's already moving cargo for PepsiCo, Walmart, and Costco. Same chassis, same motors, same battery technology. Tesla simply eliminated the cargo capacity and reimagined the interior as living space. What's fascinating is that Tesla telegraphed this move years ago, but almost nobody caught it. Back in 2022, Dan Priestley, senior manager of Tesla's Semi program, mentioned they'd eventually build a sleeper cab version for long-haul drivers. Most analysts assumed he meant adding a basic bed behind the driver's seat. But Tesla investor Sawyer Merritt just revealed that a Gen 2 Semi is coming when full Nevada production starts. And that version is the sleeper model Priestley teased. This isn't a side project, it's been part of the Semi roadmap from the beginning. Now here's where the engineering gets interesting. The current Semi weighs under 20,000 pounds with an 800 kilowatt-hour battery delivering 500 miles of range. Those specs are essential for a freight hauler running daily routes, but completely unnecessary for a motorhome. Think about actual RV usage patterns. Owners drive to a destination, park for weeks or even months, then move to the next location. Tesla recognized this and made a brilliant cost-cutting decision. The motorhome version reportedly uses a 220